so now that we've been able to identify x-intercepts and vertical asymptotes, we now want to identify what a hole, right? We want this idea of what is a hole, and so we're going to try to make sense of that in this video now. All right, we've hopefully figured out how to find x-intercepts, vertical asymptotes. Well, now how do we find a hole in a function? So one of the ways that forms get holes require the use of limits, which is in calculus, but there's maybe another way to think about it, right? So let's say the equation for this graph that we have here is y equals, it is, this problem here is asking us, well, what if we want to identify, let's go ahead, it says find your x-intercepts and identify your vertical asymptote. So what we need to do that is we need to, well, to find the x-intercepts, we set the numerator equal to 0, x plus 1, x minus 2. We're going to get 0 equals x plus 1 and 0 equals x minus 2. Here we subtract 1 of both sides. We're going to get that our x-intercepts are x equals negative 1. And then over here we're also going to get, if we add 2 to both sides, we're going to get that x equals 2. Well, that's great. Now let's find the vertical asymptotes. We do the same thing and say we set the denominator equal to 0. All right, and so you can see that I'm doing that right here. We're going to get 0 equals x minus 3 and 0 is equal to x minus 2. We add 3 to both sides and we're going to get x equals 3. And then we add 2 to both sides and we get x equals 2. Okay, so according to what we just did, all right, according to what we just did, our x-intercepts are x equals negative 1, x equals 2, but our vertical asymptotes are x equals 3 and x equals 2. And this is a problem because according to what we just did, we have that an x-intercept is x equals positive 2. And over here when we find the vertical asymptotes, we get that x equals positive 2. Right? And this right here is a contradiction. Right? It's a contradiction, and the reason why it's a contradiction, all right, is because does it make sense that we could be a x-intercept and a vertical asymptote at the same time? Well, no, it doesn't, right? This right here doesn't make sense that we could be both at the same time, because to be an x-intercept, right, means that you need to cross your x-axis, but to be a vertical asymptote means that your function does not touch it there. So if you're x-intercept, that means you're touching the function, but then the vertical asymptote means you're not touching it, right? And when we get this contradiction, that's what is considered a hole. Right? We can't be neither one of these, and that's where you're going to see this hole right there. All right? So in reality, the hole is going to be 2, x equals 2. So it's not going to be a vertical asymptote, and it's not going to be an x-intercept, right? It doesn't make sense that you could be both of these. All right, so when we get this contradiction, we can cancel them out, and we can now put in this new section and say it is a hole. All right, and you can see, well, if I took the 2 and I plug it back into my equations, right, I'm going to get 2 plus 1, 2 minus 2, all right, 2 minus 3, and 2 minus 2. And we're going to get 3 times 0, all divided by negative 1 times 0. Well, 1 times 0 is 0, divided by negative 1 times 0, it's 0. And so you could see that we're also going to get a hole, essentially, when you get 0 over 0, right? That your x-intercepts are 0 and your vertical asymptotes are 0, and this is a contradiction. And this is where we end up getting a hole. At x equals 2, right over here, x equals 2, we have a hole. All right, so again, now you'll be able to tell if you look up here in the equation, well, you can always tell when there's a hole when you get the exact same factor on top or bottom, all right? So once we get the same factor top or bottom, that lets us know where the hole is located at, and you can see that it's located at right over here. So why don't we go ahead and apply it to this other problem that we have here, okay? The equation for this one is x plus 1, x minus 1, and we're going to get x minus 5, all divided by x plus 2, x minus 2, and x plus 1. Okay, so you can see in this problem here, all right, one of the first things I want to do is, so now let's say that this problem is asking us to find our hole, our holes. our x-intercept and our vertical asymptote. Okay, so whenever now you have these three things we need to identify, well, the first thing I want to do is, do you notice any factors that are the same on the numerator and denominator? Well, I see an x plus 1 right here, and I see an x plus 1 right here, all right? Because these are the exact same things on top or bottom, just like we showed on the previous example. That tells me where the hole is going to be located. Well, x plus 1 equals 0. We set it equal to 0 and solve for it. And we know that a hole should occur when x is equal to negative 1. X is equal to negative 1. You see the hole occurs right there. All right? So now that we know that, well, because of the same thing, we can just cancel them out. All right? And we can rewrite this as x minus 1, x minus 5, all divided by x plus 2 and x minus 2. Now, if I take negative 1 and plug it into the equations in here, all right, if I take them and plug them into the numerator, and the denominator, that's going to let me know what the y value is, which is located right over here, right? And so we're not going to do that for now. We're just identifying where the x value is. But if you wanted to, now when we cancel out the same factors, top or bottom, we have this equation, and we can use this equation now to find our x-intercepts and our vertical asymptotes. So we're going to get for our x-intercepts, 0 equals x minus 1, x minus 5. All right, so 0 is equal to x minus 1, 0 is equal to x minus 5. We add 1 to both sides, and we get that x is equal to 1. Add 5 to both sides, and we're going to get x is equal to 5. For the vertical asymptotes, we're going to get 0 is equal to x plus 2, x minus 2. And we're going to get, well, 0 equals x plus 2, and 0 is equal to x minus 2. We subtract 2 to both sides, and we get x is equal to negative 2. And here we're going to add 2 to both sides, and we're going to get x is equal to positive 2. All right, so you could see, first thing I did was identify the hole, and then I identify the x-intercepts and vertical asymptotes, right? So why not go ahead and try maybe another example. Let's say we have y is equal to x minus 1, x squared, all right, minus 7x plus 10, all divided by x minus 1. Okay, so when we go to find our x-intercepts and vertical asymptotes, it's going to be so important. The first thing we do is to try to write everything into factored form. And I see this right here in general form. So let me just write all the factors of 10, 1, 10, 2, and 5. Well, you could see if I make both of these negative, it's going to add up to give me negative 7, and they multiply to give me a positive 10. So I'm going to get y equals x minus 1, all right, x minus 2, x minus 5, all divided by x minus 1. This is my new equation written in factored form. Now I kind of ask myself, okay, do you notice any factors that are the same top or bottom? Well, I notice this and this are the same thing. Because they're the same thing, I'll go ahead and write it. The whole, right, is x minus 1 equals 0. We add 1 to both sides, and we get that the whole should be located at x equals 1, right? We don't know what the y value is, but it should be located there. Let's cancel these out, and we're just going to get x minus 2, x minus 5. Well, there's nothing in the denominator anymore, right? So it's just divided by 1, right? So now we want to go find our x-intercepts. We're going to get 0 equals x minus 2 and 0 equals x minus 5. We'll split them up. And now we're just going to add 2 to both sides, and x equals 2. And now we're going to add 5 to both sides, and we're going to get x equals 5. Right? These are my x-intercepts. And for my vertical asymptotes, okay, well, there's nothing I can set equal to and solve. So there's nothing on the denominator, so there is no vertical asymptotes. All right, and that's it, and we're done. All right, well, why not go ahead and try maybe something else? Let's try something like y equals, let's say, x minus 1 divided, let's say x, hold on, let's change that up a bit. So y is equal to x minus 1 times x, all divided by x times x minus 4 and x minus 2. Okay, so my first question to ask you, do you notice, so let's try to find our holes. Do you notice anything that is the same on top or bottom? Well, I notice these x's are the same, right? It's just an x, but they're the same, and because there's nothing attached to them, we just set it equal to 0. X equals 0, and this is my hole. That's it. Now, let's go ahead and try to find our vertical, let's go ahead and find our x-intercepts. Well, we set the numerator equal to 0, right? Because I canceled out these x's, you know, I might as well just go ahead and rewrite this as x minus 1 divided by x minus 4 and x minus 2. Alright, now that I have that taken care of, well, let's go ahead and find my x-intercepts, which is just setting the numerator equal to 0 and just solving for it. And we get x is equal to 1. Now we want to find our vertical asymptotes. Our vertical asymptotes. We set the denominator equal to 0 and we get x minus 4, x minus 2. And we set these equal to 0. And we get plus 4 to both sides. X is equal to 4. And we add 2 to both sides. And we're going to get that x is equal to 2.